Okay, what's going on, guys? Let's look at this problem right here. Here this question is asking for arbitrary complex constant w1 and w2, prove or disprove the following. The first question is asking prove that imaginary w1 plus imaginary w2 is equal to imaginary w1 plus w2. Okay, so let's call this one A. Now first we have to create two complex numbers. Let's go ahead and call w1 is equal to x plus jy, and let's call w2 is equal to p plus j rho. Okay, here we have two complex number. Now we are going to prove the imaginary part of the w1, like imaginary w1 plus imaginary w2 is equal to imaginary w1 plus w2. Okay, now in order to do this one, first what we are going to do is we are going to take imaginary w1 plus w2 and we are going to add them together. So here we are going to have imaginary, and this is the w1 is x plus jy plus p plus j rho. Okay, and from this one you can see imaginary part x plus p, this is the real part, plus j y plus rho. Okay, so from this one we are looking for the imaginary part. Imaginary part is this one, right? This is real part, this is the only imaginary part. So imaginary part is going to be y plus rho. Now we have to see this imaginary w1 plus w2, that's this one, the whole thing. Is it equal to imaginary part of the w1 and addition of w2? That's true, right? This is, we can say this is imaginary part of the w1, that is y, right, plus imaginary part of the w2, that is rho. So this is true. So we proved the first one. Now let's look at the second one. So let's keep this complex number as it is. We are going to use the same complex number. Okay, we are going to do the B part. Okay, let's get rid of this one. This is now B part. Now B part asking us to prove real part of the w1 times the real part of the w2 is equal to real part of the w1 plus w1 times w2. Now let's take this part, real part of w1 times w2. Now let's go ahead and multiply and see what we get. So first w1 is x plus jy multiplied by p plus j rho. So in order to multiply this one, we have to FOIL it. FOIL mean we multiply like this, and then like this. Okay, now let's go ahead and see what we get. Real part, here we are going to have xp, and then this is going to become what? Plus xj rho, and then this is going to be jyp, and this is going to become j square y rho. So j square is -1 because j is square root of -1, so j square is going to be -1. So this is going to be negative y rho. Okay, so this is what we are having right now. Here we are looking for the real part. If you separate the real part alone from this one, you can see wherever we have a j, this is imaginary, this is also imaginary. So the real parts here is xp minus y rho. This is the real part, and we have to see whether it is equivalent to this one. Like when they say real part of w1, real part of w2, it means we have to look at the real part of the w1 and real part of the w2, x times p. That's what we are expecting right here, but it's not giving that. It's giving x times p but minus y rho. This is not what we are expecting, right? So it means we disproved this one. This is disproved. It means this is not true. We cannot prove this one. This is not correct. Let's go for the third one. The third one, let's use the same complex number, but I'm going to write it again. Okay, so let's go ahead and create the third complex number. So first w1, let's call w1 is equal to what? X plus jy, and then w2 is going to be p plus j rho. Okay, now what we are going to do is we are going to see if we divide these two, how are we going to get, like we are expecting imaginary w1, imaginary w2. Imaginary w1 is what? Y over rho. So that's what our expectation. Y over rho should be final answer when we divide the whole expression. Let's see whether we get that one. So what I'm going to do, I'm going to take imaginary w1 over w2. Now let's see. W1 is what? X plus jy. Then this one is p plus j rho. Now when we have this kind of situation, we can simplify this one by multiplying p minus j rho times p minus j rho in the denominator. We have to do, if I do in the denominator, I have to do in the numerator too. So we have denominator and numerator is this one, because I'm trying to bring this pattern a minus b times a plus b, that is equal to a square minus b square. But here this is going to become plus, because if j is equal to negative square root of negative 1, so j square is going to be negative 1. So if we multiply, this is going to become what? This is going to become p square plus rho square. So that's what we are going to get, right? Because minus minus, that's going to make this one plus, because j square rho square, so j square is negative 1, so we got plus right here. Now let's go ahead and FOIL the top part like this, and the bottom part multiplies like this and like this, right? Now let's see what we get from this. X times p, xp, and then x times negative j rho, this is going to be negative jx rho, and then jyp, that's going to be plus jyp, and then here we are going to have j square is negative 1, here we already have a negative, so that's going to make this one positive, and then we are going to have yp. Okay, so from this we are looking for the imaginary part. We have to remember that imaginary part. So we are looking for the imaginary part right here. Here we can continue. Let's continue this one right here. This is going to be what? xp plus yp is the real part, minus, and if I take j common, or if I take plus j common, this is going to be yp minus x rho divided by, so we can also separate this p square rho square into two parts, like p square plus rho square, and this also p square plus rho square. In that way we can verify this j with this complex part alone, right? So we are looking for the imaginary part, and if you look at the imaginary part right here, that is what, this is the only imaginary part, right? yp minus x rho divided by p square plus rho square. Now we were expecting y over rho, because that one was the imaginary part of the w1, that is this one, and imaginary part of the w2, that is this one. But at the end we ended up with this one, right? This is not what we are expecting, so this is also disproved. So we can say imaginary part of the w1 divided by imaginary part of the w2 is not equal to imaginary part of the w1 over w2. So this one doesn't exist. And that's how we do this kind of problems. I hope this helps. Thanks for watching.